So we'll discuss one more example in magnetically coupled circuit problems. Okay, here the question is directly given in frequency domain. So the conversion is not needed. In the previous video we discussed about how do we convert the time domain circuits into frequency domain circuits. Suppose if you want to do a problem like that, kindly go through the previous video. The same the link will be available in the description also. You can so browse to the problem video. Okay, now this is very simple. Okay, so the question is calculate the phasor current I1 and I2. It has to be capital I1 and capital I2. Okay, capital I1 and capital I2. So phasor currents I1 and I2 is the circuit of figure. Okay, so the circuit is given here 12 angle 0 volt. It is already in the phasor domain or frequency domain. We have minus J4 ohms, J5 ohm, J6 ohm, J3 mutual inductance. This can be considered as L1 and L2, and we have a resistor value 12. Okay, in this problem we are supposed to find only I1 and I2. We are supposed to find only I1 and I2. Okay, I'll just if you don't know the dot convention, so kindly go through the video of dot convention and come back here so that you can understand how to write this. Okay. So here, so while applying KVL, the current I1 is entering negative, leaving positive, so it does not obey passive sign convention. So I will be writing minus 12 angle 0. Okay, and then so the value itself is minus J4, so minus J4 is impedance multiplied by current. So this will constitute a voltage. In KVL we will consider only voltages. So minus 12 angle 0 minus J4 times I1, and there is a self-induced voltage across this. Okay, plus J5. So due to the current I1, the self-induced voltage will be generated due to the current I1 which is flowing through this inductor. Okay, there will be one more voltage called mutual induced voltage due to the current I2 flowing in J6. Okay, due to the current I2 flowing in J6, there will be a mutually induced voltage across J5. Okay, across J5. I'll use different color for that. So let us consider the current is in this direction. Okay, I2 is in anti-clockwise. So it is entering. There are two terminals for this inductor. One is dotted. In one side there is a dot. We call it as dotted terminal. In the other side we don't have dot. We call it as undotted terminal. So current is entering, current I2 is entering the undotted terminal. So this will generate, okay, and it is flowing through J6. This will generate a voltage, mutually induced voltage across J5. So the induced voltage positive also will be in the undotted. So based on where the current is entering. So in this coil, the current is entering undotted. So generated voltage in the nearby coil, positive also will be in undotted. Automatically negative polarity will be in the opposite side. Okay, and then the mutually induced voltage will be written based on the mutual inductance J3 multiplied by the current which is causing it. Which current is generating the voltage across J5? The current I2. So I need to consider the current I2 here. Okay, even though it is in loop 1, there is no connection between loop 1 and loop 2. So due to the current I2 flowing through J6, there is a induced voltage in across J5, and then the potential positive and negative polarity will be written based on the dot convention. Okay, as I already told, the dot convention video link is available. The link you can go through it. So now we know the polarity here, minus and plus. Now check the current direction I1. The current is entering negative, leaving positive. It means it is not obeying the passive sign convention. Okay, so if it is not obeying passive sign convention, I need to write minus. Okay, so and then we have J3 multiplied by I2. Okay, equal to 0. Okay, minus 12 plus minus J4 I1 plus J5 I1 minus J3 I2 equal to 0. The same equation we got. So I am rearranging the equation. I got Ji1 minus J3 I2 equal to 12. That is considered as equation number 1. So next I need to write the equation number 2. Okay, I need to apply KVL at loop 2. Okay, here also I am considering clockwise direction. So mostly this will be given in anti-clockwise. So be careful in which direction the current is given in the loop 2. That is very very important. Here it is clockwise. In some problem it will be in the anti-clockwise. Okay, so here it is clockwise. So I can start with here. We got 12I2. Okay, plus there is a self-induced voltage across this. So impedance can be written directly and multiplied by the current flowing into it, which is self-induced voltage. Okay, we got it as self-induced voltage. Impedance value multiplied by the current flowing through the same coil. We got it as self-inductance. Now the current I1 is entering, flowing through the coil 1, which is J5. The current I1 is flowing through J5, which will induce voltage across J6. Okay, but there is no connection between these two loops. Okay, so that voltage I call it as mutually induced voltage. That is due to the current I1 flowing through coil 1. So current I1 is entering the dot. So generator voltage positive will be at the dot and negative will be at undotted. It is based on where the current is entering. If the current is entering the dotted terminal, okay, in the nearby coil the generator mutual voltage positive also will be in the dotted terminal. So this polarity is written based on the dot convention rule. Based on the dot convention rule. So go through the dot convention rule to understand this. Okay, and what is the voltage, mutual induced voltage? That will be written based on the mutual inductance J3 multiplied by the current which is causing it. This mutual voltage across J6 is caused by the current I1. So mutual inductance multiplied by I1. Okay, now check the direction of the current I2. The current I2 is entering negative of the generator mutual voltage and leaving the positive, which does not obey the passive sign convention. So I'll write minus, okay, minus J3 I1 equal to 0. Minus J3 I1 equal to 0. Okay, so it is written as 12 plus J6 I2. Sorry, it is not I6, it is I2. Okay, 12 I2 plus J6 I2. It is due to the current I2. Okay, I mistakenly written as I6. So ignore it, it is I2. Okay, minus mutual induced voltage J3 I1. Okay, which is written here, which is equation number 2. So I got two equations now. Okay, and now I'll be using the equation from loop 2. I can write like this: I1 equal to 12 plus J6 I2 by J3. So what I have done? Okay, I just took I1 to the other side. Sorry, I1 to the other side. I1 would be equal to 12 plus J6 I2 by J3. Okay, I can divide 12 plus J6 by J3. I will get 2 minus J4. Please use calculator to solve that. So now there is a relation between I1 and I2 from equation number 2. So I1 can be equal to 2 minus J4 I2. So that can be substituted in equation number 1 in the place of I1. So in the place of I1 I have to substitute that. In the place of I1 I have to substitute that. So J times, okay, J times 2 minus J4 I2. J times 2 minus J4 I2. Okay, that can be substituted directly in the equation number 1. Okay, so minus 3J I2 equal to 12. So that can be simplified as 4 minus J I2 equal to 12. It is just mathematical, just substitute and write the answer, you will be getting this. Okay, 4 minus J I2 equal to 12. So I2 will be equal to 12 by 4 minus J. Okay, I am taking it to the denominator. So we will be getting 2.91 angle 14.04. Okay, now the result is represented in polar form. So learn how to convert the rectangular into polar using calculator. Okay, learn that. Otherwise watch videos. There are a lot of videos available on YouTube. So now I have I2. Now using I2 I can substitute the value in equation number 3 to find I1. So 2 minus J4 times I2. I2 is 2.91 angle 14.04 and substitute that. I will be getting 13.01. Okay, sorry. So I got 13.01 angle, 14 minus 49.39. So this is the answer for I1. So I got current I1 and I2. Okay. So if you have any doubts, please post it in the chat or comment, so I can, if time permits, I'll reply for it. Thank you.